Option 1. So the CPU follows the von Neumann architecture design, with it having the control unit, the ALU, and the registers. So the control unit manages and coordinates hardware operations, interprets instructions, and controls data flow within the CPU. The ALU performs arithmetic and logical operations on the data. And as for the registers, the memory address register stores memory addresses for fetching or storing data or instructions in the primary memory. The MDR or memory data register temporarily holds data being fetched from or written to the primary memory. The program counter keeps track of the address of the next instruction to be executed in the memory, and the accumulator stores immediate results of arithmetic and logic operations within the CPU. So there are three types of primary memory: RAM, ROM, and cache. So RAM contains RAM contains the data and instructions the computer has loaded since starting up, and everything the user has opened or loaded. This type of memory is volatile, meaning it loses its contents if power is lost. Conversely, ROM is non-volatile, and so that means that it does not lose its contents if power is lost. It stores the BIOS, which stands for Basic Input Output System, which is the first program that is booted up when the computer is booted up. Cache is a type of small high-speed memory inside the CPU used to hold frequently used data, so that the CPU needs to access the much slower RAM less frequently. The machine instruction cycle is essentially the fetch, decode, execute cycle. So the first step is the fetch. The CPU fetches a instruction from the main memory, so the RAM, and it stores it in the CPU temporary memory, so the registers. When it is fetched, to make sense of the instruction, it is decoded, and then it is executed in the execute section. So first of all, an operating system provides a user interface. So the OS has to provide a link between the user and the computer hardware, and this can be done through a graphical user interface, so GUI, or a CLI command line based. It also does memory and peripheral management, so it keeps track of storage devices like HDD. It controls what applications access to which area, RAM. They can be modified. Different locations of the memory can be modified modified, read, and written by the OS, etc. It also does peripheral management, so it manages a keyboard, mouse, monitor, printers, stuff like that. They're controlled through device drivers, and a device driver is a software program which allows hardware devices to be used by the OS. They act as translators between the devices in the computer system. And lastly, an OS also allows for multitasking. So it coordinates the working of different programs by allocating the CPU time between different programs based on time and priority of the software application. Persistent storage. So first of all, persistent means non-volatile. So when we go back to the processing that is done in the CPU, it's noticed that there's no permanent storage, only the registers. And then, so that is also, and also when the processing is carried out, it stores the data in the RAM, which is volatile. So there is a need for a non-volatile type of storage in order to save data after power is lost. So this can be done through like an HDD or an SSD. So there are a range of application softwares such as word processors, spreadsheets, DBMS, email clients, web browsers. So, for example, for a word processor, this is a program that allows the storing, manipulating, and formatting of text. A spreadsheet allows data to be arranged in rows and columns, and these can be manipulated and used in calculations. DBMS, for example, also it's a system software for creating and managing databases. It provides users and programmers with a systematic way to create, retrieve, update, and manage data. And the last example, the email client, it's a computer program that allows access and the managing of a user's email. Common features of an application. So these can be toolbars, menus, dialog boxes, and also other GUI components specific to the application. So a bit is the smallest unit of data in computing. It is represented by either a 0 or a 1. A byte is 8 bits, and a denary or decimal is a base 2 number system. No, binary is a base 2 number system, so that means that there are only two possible symbols that can be represented in this number system. A denary, on the other hand, is a base 10 numbering system, meaning there are 10 possible symbols that can be used. And as for hexadecimal, that means base 16. So this can be done in multiple ways. For example, you have different variable types, such as boolean, char, int, double, or string. Colors can be represented through hexadecimal, and as for characters, it can be represented through ASCII or Unicode. And this is where in a table, there's a binary number that's attributed to each character. So we have different Boolean operators. First of all, starting with not, there's only one input, and the output is the direct opposite. So if 0 is entered, then 1 will be the output, and if 1 is entered, then 0 will be the output. An AND operator, it takes in two inputs, and it requires both of these inputs to be true, or at 1, in order for the output to be true. All other cases yield a output of 0. An OR gate, it requires only one of the two inputs to be true or at a 1 in order to yield a positive output. A NAND is the combination of a NOT and an AND gate. A NOR means it will yield a positive output if none of the inputs are true. And a exclusive OR will yield a positive output, a one output, a true output, if one of the inputs are true, but not if both of the inputs are true. So the truth tables are presented here below. So constructing logic diagrams using these types of gates, it depends on the actual specific scenario, but just as an example, we have this logic diagram, and we can assume maybe that this represents that Q will represent whether we will be going out that day or not to the shops, and A can represent whether one shop is open, and B can represent whether another shop is open, and C can represent whether or not it is raining that day. So as long as one of these shops is open, then and also that it is not raining, we can be going out that day. And this is represented through the OR and the AND gate.